When solving the triangle, in two of the cases, we have to use the law of cosines. That is the side, side, side case. We were given the three side lengths, but none of the angles. And in the side angle side case, we are given two sides and the included angle. So those are both examples where we need to use the law of cosines. So let's look at a few examples. In triangle ABC, if angle A is equal to 29 degrees, side B is equal to 8, and side C is equal to 3, find side A and angle C. So in other words, find the missing side and angles. So let's draw a little figure to see what we're dealing with here. So we have A, B, C, and we're told that angle A is 29 degrees. This is obviously not to scale. We have that side B is 8, and side C is 3. So again, this is side, angle, side. So to start with, well, to find side A, we have exactly the information we need to apply the law of cosines. So let's remember what the law of cosines says here. We have that a squared equals b squared plus c squared minus 2bc times the cosine of a. And again, we have everything that we need here. We have b, we have c, and we have angle a. And so that'll allow us to solve and find for side a. So plugging in, we get a squared plus 3 squared minus 2 times 8 times 3 times cosine of 29 degrees. And when we compute that, we get about 31.02. So taking the square root, we get that A is roughly the square root of 31.02, which comes out to be 5.57. So that's what side A is, 5.57. All right, now to find angle C, we'll use the law of cosines again. We could use the law of sines, but it's easier and it's always safer to avoid the ambiguity that the law of sines sometimes has. So it's easier just to use the law of cosines again. So for the law of cosines, now we want to include our angle C, and so we need to use the form of law of cosines that involves C on the left side. So c squared is equal to a squared plus b squared minus 2ab times the cosine of C. So now we have all three sides. We have A, B, and C, and so now we can use that to solve for C. So we find the cosine of C. If we move this over and rearrange, we get a squared plus b squared minus c squared all over 2ab. That's just rearranging the law of cosines. And now, plugging in what we know, we've solved for A, we know B and C, and so we plug in, and I'll leave the computation to you, but this computation comes out to be approximately 0.965, and so we take the inverse cosine, we find that C is inverse cosine of 0.965, and that turns out to be about 15 degrees. So now we found C, and the question didn't ask for angle B, but of course, knowing that C is approximately 15 degrees, we can find B just by subtracting, taking 180 minus 29 minus 15 to find what angle B is, and that turns out to be 136. Okay. So now we have a triangle ABC where we're told that angle A is 70 degrees, side B is 9, and side C is 5. We're asked to find the other side, A, and the angles B and C. So let's draw our figure and see what we got. So here's A, B, and C. And we have 70 degrees is A, side B is 9, side C is 5, and we're asked to find A, and angle B, and angle C. Alright, so again we have side, angle, side. So we're going to use the law of cosines is perfectly suited to find side A. So we set that up. A squared is B squared plus C squared minus 2BC times cosine of A. And again we have everything we need, B, C, and A. So we can plug in. So B we get 9 squared, C is 5 squared minus 2 times 9 times 5 times cosine of 70 degrees. And now, when we evaluate this, we find that this is roughly 75.218. And so A is the square root of that, which comes out to be approximately 8.673. So that's what A is. And now we have all three sides. So to find the other angles, well, we can pick an angle and use law of cosines to find it, and then the third angle we can find just by taking 180 minus the other two angles. So let's pick angle C, and we'll use the law of cosines again. So to involve angle C in the law of cosines, we need to use the form that says C squared equals A squared plus B squared minus 2AB cosine of C. And rearranging this and solving, we find out that cos of angle C is equal to A squared plus B squared minus C squared all over 2AB. And plugging in what we know, because we know A, and we found A, and we were given B and C, we can plug in and solve, evaluate that. And what we find is that this is roughly 0.84. So evaluating the inverse cosine, so C is the arc cosine or inverse cosine of 0.84, and that comes out to be about 33 degrees. So that's what C is, and then to find B, we just need to take 180 minus angle A and angle C. So 180 minus 70 minus 33. So that's 180 minus 103, which is 77 degrees. So that's what B is. So again, in a side angle side situation, we use the law of cosines to find the unknown side and then the unknown angle. Now, in a side-side-side situation, we'll see how we can find all of the angles of a triangle. So here we're given triangle ABC with sides 7, 5, and 10, and then we're asked to find the angles. So let's draw this. So we're told that side A is 7, side B is 5, and side C is 10. Okay, so here's a situation where certainly law of sines won't work because we don't know any of the angles, and so our only hope is to use the law of cosines. And so let's just pick an angle and start and see what happens. So let's try and find angle A first. And so remember, the law of cosines that will involve angle A looks like this. It'll be A squared equals B squared plus C squared minus 2BC cos of A. So that involves our angle A, and we know sides A, B, and C, so we can rearrange this and solve for cos of A, and that will then we can take the inverse cosine to find angle A. So solving, we get that cosine of A is equal to b squared plus c squared minus a squared all over 2bc. Now plugging in the values we know for b, c, and a, we can find that this evaluates to 0.76. And once we take the inverse cosine, we'll find a. So a will be the inverse cosine of 0.76, and that comes out to be about 41 degrees. And now we could use the law of sines, but let's just keep going with the law of cosines and to find angle B. And so to find angle B, we'll use the law of cosines that involves angle B. So b squared equals a squared plus c squared minus 2ac times the cosine of b. And similarly to what we did here, we rearrange this and solve for cos of b. We get cos b is equal to a squared plus c squared minus b squared all over 2ac. When we evaluate this using all the sides that we know a is 7, c is 10, b is 5. What we find for this is that cos of b is approximately 0.886. And so knowing that, we can take the inverse cosine to find what b is. So b will be the inverse cosine of 0.886, and that comes out to be about 28 degrees. So now that we've found a and b, we don't need to bother using the law of cosines yet again to find c. We can just take c to be 180 minus a minus b. So c is 180 minus a minus b, and so that comes out to be 180 minus 69, which is 111 degrees. So there we found angle A, B, and C given the three sides of our triangle. So now we're given a triangle, and we're told the three side lengths, A, B, and C, and we're asked to find the angles, A, B, and C. So let's draw a picture and see what happens. So side A is 10, side B is 7, and side C is 16. Well, and again, we're going to use the law of cosines because there's no way we can use the law of sines without any angles given to us. So we'll use the law of cosines. And in this case, let's start with angle A. We really can pick any angle to begin with. So let's start with A. And so we use the law of cosines, which relates angle A with the sides. So a squared is equal to b squared plus c squared minus 2 bc times cosine of A. Rearranging this and solving for cos of A, we get cos of A is b squared plus c squared minus a squared all over 2bc. And when we plug in the values we know for A, B, and C, we find that this is 0.915. So now from that we can find what A is by just taking the inverse cosine of 0.915, and what that comes out to be is approximately 24 degrees. So that's what A will be. And now similarly, we can find angles B and C, or either one of them using the law of cosines, and then we'll find the third by just taking 180 minus the two angles that we found. So let's find angle B using the law of cosines. So a similar process to what we did there, we'll find that cos of B is equal to a squared plus c squared minus b squared over 2ac. That will be the same thing, just rearranging again. And what we find by plugging in the values that were given is that this is approximately 0.9 1.959. So taking the inverse cosine, what we find is that B is approximately 16 degrees. So that's A and B. So we define C, we just take C to be 180 degrees minus A, which is 24 degrees, minus B, which is 16 degrees. So that's 180 minus 40, which gives us 140 degrees for C.